1.7 Inverse trig functions. In order to have an inverse function, the function has to be one-to-one. So recall what one-to-one functions are. We need to perform vertical line test. So here's the sine graph. So y equals sine of x. And we see it's not one-to-one. It is not one-to-one. One-to-one function passes the horizontal line test. So you draw a horizontal line, and if it intersects more than one point, then it's not one-to-one. So to make it one-to-one, we need to restrict the domain so it is one-to-one. So let's decide how we're going to restrict the sine. Since the sine starts at 0, so we can't go past pi over 2, but we can go this direction. And let's say from negative pi over 2 to pi over 2, we restrict the domain. That's one example. You can pick a different interval, but this is around the origin, so it's convenient. So in this interval, y equals sine of x is 1-to-1. So we can talk about the inverse. And the inverse will be called arcsine. That's one way to write it, or sine negative 1x for inverse. So definition. The arcsine function is a new function, y equals arcsine of x, if and only if sine of y equals x. So recall the inverse functions we obtained by switching x and y, and that's what we did. So x, the input for our arcsine function, is the number between negative 1 and 1. Remember, that was the range for the sine. And the range for the arcsine, or y, is what was x for the sine function. In other words, it's from negative pi over 2 to pi over 2. So this is the domain for the arcsine, and this is the range. When we find inverses, we realize that the domain and the range interchange. So what was the domain for the sine? Negative pi over 2 to pi over 2 becomes a range for the arcsine. Example A. What is arcsine of negative 1/2? So in other words, we're asking the question, sine of what angle? We don't know, so we say theta is equal to negative 1/2. We can look in the unit circle and see where negative 1/2 is. Sine measures on the y-axis, so here's negative 1/2, and so there are two angles, one in third and one in fourth quarter, whose sine is negative 1/2. But because of our restricted domain, so our domain was from negative pi over 2 to pi over 2. So that means, I'll write this down here, first and fourth quadrant, first and fourth quadrant. So our angle that we want, theta, is in the fourth quadrant, and so we're going to name it negative pi over 6. So the angle theta here is negative pi over 6, which is in the desired interval. Example B, sine negative 1, or inverse sine, of root 3 over 2 is equal to what? So we can think about the table that we memorize and figure out sine of what angle is root 3 over 2. And again, we have to be in the first and the fourth, or the fourth quadrant. But since sine is positive in the first quadrant, we know that the angle whose sine is root 3 over 2 is pi over 3. C, what is the inverse sine of 2? In other words, we're asking sine of what angle is 2? Well, that's not possible, because we recall that sine of an angle is always a number between negative 1 and 1. So this has no answer, or not possible. now graphing the arcsine. So we want to graph our arcsine. Graphing y equals arcsine of x. So we're going to help ourselves with first graphing the sine in our restricted domain from -π/2 to π/2. This is the graph of our sine that is 1 to 1 in this interval. And we're putting here the domain and the range. So maybe I should write this down. This is from -1 to 1. So for the sine, we're talking about the sine here. The domain, these are all x's, is from -π/2 to π/2. We restricted it, so it's 1 to 1, and the range is -1 to 1, always. Now, when we graph the inverse sine or the arcsine, we remember the x and y switch. In other words, the domain here would be whatever the range was, -1 to 1. So -1 to 1, and the range would be what the domain was, -π/2 to π/2. So here you go, -π/2 to π/2. And we can make a table here for the sine. This is the table for the sine, and we can look at the graph, or yeah, let's look at the graph. Here's one point, -π/2 gives you -1. So that's that point, the beginning point right here. 0 goes to 0. We can do more points, but I'm just going to do π/2 and 1. Now, when we make the table for the arcsine, we switch those. So it'll be -1, -π/2, 0, 0 remains, 1 π/2, and we can include more points. But what's happening is that this point here, this point, -π/2, -1, now becomes -1, -π/2 right here. The 0, 0 remains here, and this point here. And so when we connect with a nice curve, this is the graph of the arcsine. Now, other inverse trig functions, other inverse trig functions. So we did only sine so far. Now the cosine is not 1 to 1 either. So the cosine looks like this. And it's not 1 to 1. Okay, to make it 1 to 1, we restrict the domain, but this time, not in the same interval because it wouldn't be 1 to 1. We're going to restrict it like this, from 0 to pi. So this part from 0 to pi makes it 1 to 1. So we can make a table like we did before to find the graph of the arc cosine, or we can think this point here at the beginning of our cycle is 0, 1. If you switch it, it becomes 1, 0. So 1, 0, let's say it's here. That point, this point over here is pi/2, 0. It becomes 0 pi/2 right here. And last point, which is pi -1, becomes -1 pi. So -1 pi somewhere here. So if we connect, then this is what the inverse cosine looks like. Oops. A little bit more smooth here. Have a hard time. Okay, here you go. Still not good. Okay, So let's write down this point here, it's 1, and this is -1, and this point right here, it's pi. Okay, so let's summarize so far what we have for our functions, their domain, and their range. So first we had the arcsine, and that is possible if and only if sine of y is x. So the domain was from -1 to 1, and the range from -π/2 to π/2. Then we introduce the arc cosine, and that is possible if and only if cosine y is x. The domain is the same, which was the range of the cosine, and the range is what was the domain, the way we restricted the cosine to be 1 to 1, and it's from 0 to pi. And here's another inverse function, the arctan, and that is possible if and only if tangent of y is x. Now here, x can be anything from -∞ to infinity, and the range is from -π/2 to π/2. We can see that, we can show the graph. Here's the tangent, the graph of the tangent in one period from -π/2 to π/2 look like this, and it's already 1 to 1, so we don't have to restrict it any other way but just from -π/2 to π/2, just like we said here, not including the π/2 -π/2 because that's where you have the asymptotes. So then the arctan will look like this. The vertical asymptotes become horizontal asymptotes. So this is π/2 and -π/2, and the graph looks like this. So same shape, but rotated 90 degrees. So example, evaluating inverse trig functions. Evaluating inverse trig functions. Example, find the exact value of arc cosine √2/2. So we are asking what angle, theta, has cosine that is √2/2. Well, that should be easy. Remember our restrictions for the cosine was from 0 to pi, and we know there's one angle, exactly one angle, and that is π/4. Why? Because cosine of π/4 is √2/2, and π/4 is from 0 to pi, so it works. So B, what is inverse cosine of -1? In other words, cosine of an angle equals -1. What is that angle? Whose cosine is -1? Think about the unit circle. That is obviously pi. So that's equal to pi. C, arctan of 0. So tangent of what angle is 0? We're looking for the angle whose tangent is 0, and we know that that is 0. And what was the restriction here? -π/2 to π/2. And so 0 is inside, so it works. D, tangent -1 of -1. So now we need to look for an angle in the first or fourth quadrant whose tangent is -1. So we know it's not in the first quadrant because that's where tangent is positive. So it has to be here. And what is that angle? It's -π/4. So it is the angle in the fourth quadrant. Now, we often use a calculator whenever we have to evaluate inverse function at certain values we're not familiar with, or they're not in the table we've memorized. So using calculator, let's practice arctan of negative 8.45. So your calculator has a button that says tan negative 1. That's the same as arctan. All you have to do is type arctan or tan negative 1, then the number, and you should get negative 1.45 in radians. So you need to watch whether you're in degrees or radians. So B, sine negative 1 of 0.2447, you should get 0.247. C, arc cosine of 2. If you enter this on your calculator, it's going to give you error, which means not possible. We know that there is no angle whose cosine is 2. Okay, last topic, composition of functions. So when we compose two functions, f and g, we have a new function called a composition. But when we compose a function f and its inverse, then it's very special, because when we compose them, it's like we are doing the function f, then the inverse, and we're going back to x. And the order doesn't matter, because you always go back to the input x. So inverse properties of trig functions. Inverse properties. So if x is between negative 1 and 1, and y is from negative pi over 2 to pi over 2, then if we compose the sine and inverse sine or arc sine of x based on what I wrote here, based on those two formulas, this is exactly x. And if we do arc sine of sine y, reverse the order, you get y. But you need to have those restrictions for the cancellation process. X has to be between negative 1 and 1, and y between negative pi over 2 and pi over 2. So let's write the same thing now for the arc cosine. So if x is between negative 1 and 1, and remember what was the restriction that we put for the cosine graph to be 1 to 1? It was from 0 to pi. Then cosine of arc cosine x, it's exactly x, and arc cosine of cosine y is exactly y. But again, the restrictions here are very important. Only for those x and y, we have the cancellation. Sometimes we call this the cancellation equations. And finally, if x is a real number, no restrictions, and y, it's between negative pi over 2 to pi over 2, but no equal sign here because of the vertical asymptotes of the tangent, then tangent of arctangent of x is x, and arctangent of tangent y is y. So example, what is arc sine of sine pi over 2? First, make sure you're in the right restriction. So for the sine, we wanted y to be from negative pi over 2 to pi over 2, including, so it is. So this is gonna cancel arc sine and sine, and you have pi over 2. It's very simple. However, if we want arc sine of 3 pi over 2, 3 pi over 2 is not in the interval negative pi over 2 to pi over 2. But what is the coterminal angle of 3 pi over 2? Well, it is negative pi over 2. So that's why this is equal to negative pi over 2. You can make a note here, 3 pi over 2 and negative pi over 2 are coterminal. In other words, they have the same initial and terminal side. So here is 3 pi over 2. That angle is coterminal or has the same sine and cosine as negative pi over 2. And that concludes the lecture for 1.7.